All right, here we are in chapter 2, where I introduce what really is the most important concept of the entire year, the focal concept of the year, um, the concept to which we will return again and again in every chapter. We're about to introduce a way that one can organize code, and this will be almost universally the way, no, I'll revise that. It will be universally the way that code is organized in this class. And that concept is the concept of a function. Now, that concept is somewhat complex, let's take a little while to discuss what this concept is, okay? And I think the best way to do this is just simply, first of all, with an example of a function in Python. Now, I would suggest that you go and read actually the chapter 0 of thinkfunctional.net. It talks a bit about mathematical functions and how those are related to functions in Python, and ultimately, the concept is one and the same, though the syntax, that is how it's represented, is a bit different. But here right now, let's simply have an example in front of us, and then we will talk about what it is that this does. Now, should perhaps apologize. I honestly do prefer to be able to explain every bit of code as I write it. But this will be an example where I'll simply write a little bit of code, and it will only be 3 lines, but still multiple lines. And I won't begin to explain it until the code is actually written. So sometimes it has to work like that. All right, so let's begin to write a function. So open up REPL or whatever code editor you use, and then let us write a function. Okay, so a function always begins with the keyword def, and remember what we mean by keyword. That's a word that is in use by Python. It cannot be used as a variable, for instance. So there it is, def, of course, short for definition. So what we're about to do is define a function. Now, after that comes the name of the function, and the name of the function is our choice, okay? Just as when we created variables and assigned them values with the assignment token, the variable name was our choice. Well, it's our choice here as well. And it is a name just like the other names that we've seen, and it will be the name of, ultimately, a function, which is, for us, a new kind of object. Now, what are the rules for name choice, for name formation? The same as before. We can use letters, both lower and uppercase. We can use digits. We can use the underscore, but we cannot begin with a digit. Okay, so here's what my function will be. It will be a function called square. Now, after the name of the function comes a set of open parentheses that, of course, will be matched off with a set of closed parentheses. And then inside of this comes a variable. Okay. Oops, I misspelled square, didn't I? So let me go ahead and fix that. Of course, Python doesn't care. You can spell it however you like, but we'll spell it in the usual way, Square. Okay, so we then have a variable inside of parentheses, and like I said, I'll describe what happens with all of this once it's actually written out. And then the very final symbol is a colon. So this is how functions always begin. So def, and then function name, open parentheses, some variables. We have only one in this case. Tomorrow we'll look at instances where we have multiple variables separated by commas, and then the colon. Okay. Now, we have to talk about what that colon does in Python. The colon is very common. Uh, now, I can begin to explain what the colon means in Python when I hit the return. So I hit return. Hopefully you hit return as well. Notice what just happened. Python automatically indented. It indented by 2. That's the way that REPL decides to do its indentations. More common in Python is 4. I'm sure that REPL chose 2 because there's so much that has to happen on the screen, and it didn't want to take up too much space in the code editor. But indentation. Okay, so what does indentation mean in Python? Well, it's white space that syntactically matters, okay? That syntactically matters. And what does that mean? Well, we've seen white space that doesn't matter, right? Remember I told you that I very commonly put a space before and after arithmetical symbols like, 2 space plus space 3 instead of just 2 plus 3 because it's easier to read. Those spaces are syntactically inert, as it were. They don't mean anything at all. And Python ignores them. However, the spaces here on line number 2, a line after a line that ends with a colon, those mean something. Okay, and I should go ahead and tell you what it means. It means that we're about to have a grouped block of code. Okay, the way that Python groups code is by indentation. And a number of statements are grouped together when they are indented by the same number of spaces from the left-hand margin. Okay, so here we go. So I tell you what, I am going to create another variable, which will be called the square. And that will be x squared. And then, oh, here's another keyword. Okay, so we're about to finish out the definition of the function. And this is the way that function definitions end, is with the so-called return statement. And that's our second keyword. Okay, our first keyword was def. Our second keyword is return. That's a word that Python has already defined for us, and we have to use it in this case. And so we will return the square. Okay. All right, so we've written some code, okay, and it has a number of new features. So let's begin to get a grip on, begin to understand what it is that this code does. And I think perhaps the best way to do that is just simply to run it. Okay, so I hit the run button. Hopefully you hit the run button as well. Notice that nothing appeared in the console, um, but notice as well that we didn't get any error message either. Okay, so Python actually executed our code and didn't find any mistakes in it, which is good. So what has happened? Okay, what does Python now know to do? What is it now able to do that it didn't know before? Well, it knows the definition of our function. Okay, it knows the definition of our function, which means that we can now, here's a word for you, call the function. And what does it mean to call the function? It means to execute that indented code that is inside of the function. Okay, we're about to make that happen, lines 2 and 3. But to make that happen, okay, look at line number 2, for instance. Well, line number 2 needs a value for x, doesn't it? Because what line number 2 wants to do is it wants to square the value of x and then assign that to the variable the square, and then return the value of the square. So to call this function, we need a value for x. Okay, so we're about to call the function, and we'll do that by its name, and we're about to send a value for x. Okay, so here we go. So square 5. Okay, so this will be a function call. And what will happen? Okay, so let's talk about what will happen before we actually hit return. Okay, so we're about to actually execute the body of the function. That's lines 2 and 3. Oh, here's a word for you. Line number 1 is the header of the function. It's the first line. And then everything else is the body of the function. So we're about to execute the body of the function. But when we do that, x will have the value of 5. So that 5 in my function call inside of the console is sent to the function and becomes the value of x. And then we execute line number 2 with x equal 5. So the square becomes 5 squared, which is 25. And then, oh, we return the value of the square, which is the value of that function call. Okay, and remember how the REPL works, right? When you hit return, it evaluates the expression on that line. It prints the value that results. And what's the value of a function? It's the value that's returned. I'll say that again. Okay, that's what the return statement really does. It gives us the value of the function, and the value of a function is the value that it returns. Okay, so a square with 5 in parentheses is a function call where 5 becomes the value of x, then the body is executed, and then the value of that expression, square 5, is the value that is returned, which will be 25. So we just squared 5, right? Which in a way should be perfectly intuitive because that's what the square of 5 is, but we need to understand the details of this so we can actually write correct code. Now here's something that's really, really cool. You can call the function multiple times, okay? You want to square 2? Ooh, that's 4. You want to square, I just hit the up arrow. Remember, you can do that. You want to square negative 2? Ooh, also get 4. Want to square negative 22? That's something or another, 484. Want to square 0? Isn't that cool? Okay, we now have our own defined function that which we can run as many times as we want. Okay, as many times as we want. Okay, so there it is, the basics of a function. Okay, and this is something that we're going to talk through multiple times, especially here at the start of our study of functions. I know that this is a bit of a jump in level of sort of complexity and subtlety from what we had back in chapter 1, but the concept of a function is so extraordinarily important that I did decide that it had to be introduced early on. Okay, so my promise to you is that we'll talk about functions multiple times. Okay, so I'd like to show you something else. What we did in this case was, we wrote the function in the code editor, then we hit the run button, and then we called the function with various input values in the console. You can also call the function inside the code itself. Okay, so I'm going to go back and do a little bit of work in the code editor. So I hit return a couple of times, and notice that I'm still indented to the left. That is, the assumption of the code editor is that I wish to continue to work on the body of the function, but I don't. So I just hit backspace. Um, to indent back over to the left-hand margin. And this matters, okay? I now want to write some code that I don't want as part of the body of the function, okay? And this is something that you will do, okay? You will not pay attention to indentation, and then there will be some code that you don't want to be part of a function, but it's indented the same amount as the function and immediately under the body of the function, so it will count as part of the function, and you'll have to go back and change your indentation, okay? Indentation matters in Python, okay? In some other languages like Java, for instance, it's just there to help the human reader. In Python, it actually syntactically matters, okay? And you'll have to pay attention to it. And you'll have syntactic bugs multiple times that involve indentation. Okay, so here's what we're going to do. So we're actually going to call the function inside of the program itself, okay? And let's just simply assign it to s. Okay, so s is going to be the result of square called on 5. Okay, so let's just simply think about this line of code for a little bit. Line number 5 is a variable assignment statement. The variable is on the left-hand side, and then you know how variable assignment statements work. Okay, so we look on the right of the assignment token at the expression that is found there. We evaluate that expression, and then the value that results is assigned to the variable on the left-hand side. Okay, so the expression on the right-hand side is a function call. That is, we will call the function square and send it the value 5. 5 will then become the value of x. X will be squared, and that will be assigned to the variable the square, and then the value of that, of the square, will be returned. So the value of square 5, which I've told you before is the value that the function returns, will be 25, and then 25 will be assigned to s, and then we can print the value of that s. Okay, so let's run this code. And then, yeah, there it is. Okay, it's 25. So this is an example of a function. Okay, a function. Now, let's just talk a little bit about this. There's a distinction that's been implicit in everything that I've said so far. And I want to make sure that this is actually clear. So I tell you what, I'm going to go ahead and simplify this a bit. Let me just delete that out and then run again, okay, which means that our function has been created. Okay, so let us make a distinction between function, that's number 1. Number 2 is function call, and number 3, function value. Okay, so I'll say those 3 again. Let us make a distinction between function, function call, and function value. Okay, well, what's the function? The function is what you see on lines 1 to 3, okay, and its name is square. Now, here's something that we can do. Let me show you an example. So remember what happens if you do something like this in the console? So I assigned the value of 5 to the variable a, and then if I type a into the console, it reports back the value. That's just how the console works. Well, square is a name, okay, and what is its value? It's a function, okay? It's a function. So notice what I didn't do. I didn't actually execute the function for some particular input value. I just simply gave the name of the function, and Python dutifully reported that indeed it is a function. And if you're curious where it says function square at and then 0x7f2, that indicates the memory location in hexadecimal where the function is actually located, because Python doesn't really know what else to tell you about the function. But anyway, the important part is that it's told us that, hey, that's a function, you know? Okay, and we could actually do type as well. Remember the type function? So type square. Ooh, it's a function. Okay, it's a function. So that's the function. Okay, we typed its name into the console. Now, here's something related but different, okay? So now we have square with 5 in parentheses. This is not just the name of the function. This is a function call. What is a function call? In a function call, we actually execute the code that is contained in the function. That is the body of the function. And of course, we need a value for x when we do that. That's one of the input values that's specified on the header of the function back there on line number 1 in the code editor. Okay, so this is a function call, and then 5 becomes a value of x, and then we execute the body of the function. Yeah, so that's a function call. Okay, a function call actually sends values to the function, okay, to the inputs that are specified. And I suppose I should go ahead and give you a name for this. I just highlighted that x on line number 1. That's often called a parameter. Okay, that is one of the variables that's contained in parentheses after the function name on the function header. Okay, so what happens in the function call is that we actually send values to the function's parameters and then execute the body of the function. Okay, which is, different from the function. I think a really, really good analogy here is this is like a recipe. Okay, a function is like a recipe. It's a set of instructions that you could or could not follow, right? I sometimes read recipes and never actually make them, right? So the function is the recipe, right? Well, what is the function call then? The function call is making the recipe, okay? That is like actually gathering together the ingredients. Those are like the inputs to the function that you need to make the recipe, and then like actually executing what the recipe says, right? Doing what it tells you to do. And yeah, okay, so there's a recipe. There's actually making the recipe. That's what a function call is. And then the final part of this that I wanted to discuss is function value. Okay, now what's the function value? It's what's get printed in the console. Okay, because that's what the console does, right? It reads, evaluates, prints the value that results from evaluation, and then loops back. Okay, so the value of square 5, that is the function value, is 25. Okay, and how does that come about? Well, as I told you before, the value of a function call is the value that is returned. Okay, so on line number 3, we return the value of the square. So there we go. And what is that in our analogy to recipes? Well, the function was the recipe. The function call was making the recipe. And then the function value, the value returned, is like the dish, okay, that you made with the recipe, what you can actually sit down and eat. So you get this distinction, right? There is the recipe, which can exist even if you never make it. And then there's the making of the recipe, the executing of the recipe, right? Which is all that work that you have to do to actually, make what the recipe tells you how to make. And then finally, there's the dish, the food that gets made. Okay, so that's the function call, and the function value.